Uh, Hello. So we are starting the logs section or the logarithms. Um, the most important thing in logarithms is understanding this right here and how this means this. So log base, we call this is the base of the log. M, what you log in M equals B. So if we switch this to exponential form, what this becomes, A becomes the base, B becomes the exponent, and M is what it equals. So basically M equals the base A to the power of B. Before doing this chapter, just spend a little bit of time to understand how this works, because this will help you quite a bit if you understand how this works. So let's go and do some examples. And the examples I'm going to do are right here. So evaluate each logarithm. So I'm giving you log base 749. And I want to know what this equals. So you have to ask yourself, what's this asking me exactly? So I know this is the base. It's to the power of something equals 49. That's what it means. 7 to the power of something equals 49. So that's what you need to find out. So 7 to the power of something equals 49. So 7 to the power of 2. So your answer is 2. And I'm just going to write the answers in red. So the answer is 2. That's what it means here. So if I ask you what's log base 749, basically I'm asking you 7 to the power of what equals 49, and therefore it's 2. Same thing. Log base 6 equals 1. So I'm asking you again, 6 to the power of what equals 1. Of course, anything to the power of 0 equals 1. So the answer here is 0, because 6 to the power of 0 will give you 1. This here, I would change it a little bit. So I'll make it log 1 over 1,000, because this is the thousandth decimal. And therefore, I'm going to change that again to log 1 over 10 to the 3, which equals log 10 to the negative 3. And that would equal, so basically here, if I don't write the base, here we had a base of 7, here we had a base of 6, but here I didn't write what the base is. If we don't write what the base is, it's base of 10, and that's what your calculator is programmed to. So if you see that log button on your calculator, it's log base 10. So if we don't indicate anything else for the base, then just know and assume it's 10. So now what am I asking? I'm asking you 10 to the power of what equals 10 to the negative 3. So obviously that's negative 3, because 10 to the negative 3 will equal 10 to the negative 3. And we'll learn about some log rules in the ahead of this session that maybe allow you to manipulate this a little bit differently, but just know this concept. It's very important to understand this concept right here. And if we go to D right here, what I'm going to do, I'm going to change this to log base 2, 8 to the power of 1/2, because the square root is the same as the power of 1/2. Then what I'm going to do is manipulate this a little bit more, and I'm going to change this to log base 2, because 8 is 2 to the power of 3. So I'm just going to change this to the 2 to the power of 3, and then we still have the half outside, which gives me log base 2, 2 to the 3 times a half is just 3 halves. And therefore, 2 to the power of what equals 2 to the 3 halves? Obviously, it's 3 halves, because 2 to the power of 3 halves equals 2 to the power of 3 halves. We're going to do a few more questions after this, just to manipulate logs according to this rule right here, in a different way than what we are doing here. Here's other questions with different approaches to solving for the variable x. So we have this question right here, A. So again, you still have to go back to this. Now, if you look at this and try to manipulate it to this, then 4 is the base, x is what you log, and then -2 is the exponent. So therefore, this will give you x equals the base, which is 4 to the power of -2, which in turn equals 1 over 4 squared. You remember, if we have a negative exponent, we flip, we make the exponent positive, and therefore the final answer will be 1 over 16. Next question. We have this. So again, x would equal 16 to the -1/4, which is the same as 1 over 16 to the 1/4, because always we don't want to deal with negative exponents, so flip, we make the exponent positive. Now, this right here, I want to change it from exponential form to radical form. So therefore, b, which is the 4 here, becomes the radicand, which is the square root, and then 1 is the a, and that's what the power of 16 is going to be. So therefore, this would equal the 4th root of 16 to the power of 1, and you don't have to write the power of 1. The 4th root of 16 is 2. So basically, the 4th root of 16 is the number that when you multiply it by itself 4 times, it gives you 16, and that's the answer. One more question here. We're solving for x, and x here is the base. So therefore, 9, just to make sure that this is a 9 and not an a. Now, again, you go back to this and change it into exponential form. So therefore, 9, just gonna be consistent and write my answers in red. So 9 equals x to the 2/3. To solve for this, basically what you need to do, just multiply both, and this has a 1, by the way, both exponents by the reciprocal of this to get rid of the 2/3 here. So multiply this by 3 halves and multiply this by 3 halves. So therefore, you have 9 to the power of 3 halves equals just x to the 1, because this will cancel. Now, again, we're going to change this from exponential form to radical form, and this will give me the square root, because the 2 is the square root. And when it's 2, we don't write it here, because when we say square root, there's an imaginary 2 there that we don't write it. And then 9 to the power of 3 would equal x. And therefore, now if you look at this, it's better to do the square root of 9 first instead of doing 9 cubed. Then your numbers will get big on you, and you'll need a calculator to do it. But if you go, okay, square root of 9 is 3, 3 cubed is 27, and therefore x equals 27. Now we're going to do a few more questions. Maybe they look a little bit more challenging, but really, if you dig down deep, you're just doing the same thing again and more steps. So if you're doing this, what you want to do here, you want to work hold on a second here. You want to work with this first, and then with this, and then eventually with this. So let's rewrite this as log base 2 of log base 3, and we need to solve this right here. So log base 4 is 64. Again, it's asking me 4 to the power of what equals 64, and we know that's 3. So there we go. Equals. Now we want to solve this. What's log base 3? 3, basically asking me 3 to the power of what equals 3. That's obvious, at least to me. So 3 to the power of what equals 3 is to the 1, basically. So still have the log base 2 here. And then this here gives me 1. Because log base 3, 3 to the power of what equals 3, it's 1. So all of this is 1. Now, log base 2, 1 equals, so it's asking you 2 to the power of what equals 1, it's 0. So as you see, you just have to work with this first. And then this is 3. Now you have this log base 3, 3, and so on. So these kind of questions, that's what you have to do. Now, with this here, we want to find out what this is first. So now, I just introduced another rule in logs. If you have log base a x to the power of b, you're allowed to bring the b down and put it in front of the log. So I'm just going to take this on the side and solve it. So log base log 10, 16, I could bring the 16 down because it's an exponent in front of the log. And then this becomes log 10. Now, since the base of the log, if I don't write it, it's 10. So for this portion right here, it's asking you 10 to the power of what equals 10. Obviously, it's 1. So all of this log 10 equals 1 is maybe something you should remember, that log 10 is always 1. 1 times 16 is 16. So all of this just becomes 16. So now we have log base 4, log base 2, and we said all of this equals 16. Now again, we go back to this 2 to the power of what equals 16, because we want to do this first. So log base 4, log base 2, 16, 2 to the power of what equals 16, 2 to the power of 4 equals 16. So now this becomes log base 4, 4, which is asking you 4 to the power of what equals 4, and it's 1. And that's your final answer with this. One more question. Determine the x-intercept of y equals log base 7 x plus 2. We will talk about graphing logs later, but every time you want to find an x-intercept, you want to make y 0 and solve for x. So that's what we need to do here. So 0 equals log base 7 x plus 2. Now this is exactly like this, where here a is the base 7 and 0 is in where b is, so that's going to be the exponent, and m here is just an expression, which is x plus 2. So therefore x plus 2 should equal 7 to the power of 0, which is x plus 2 equals anything to the power of 0 is 1, and therefore x equals, you move the 2 to the other side, becomes minus 2. 1 minus 2 is negative 1, so x equals negative 1. We're done for this session. Math is like a puzzle, and it's fun to solve puzzles. So the next time, take care. Bye-bye.